Hello, it's Brad here with the Canada Masonry Design Center, and today I'm excited to be telling you about the new version of the MAS software that we have, Masonry Analysis Structural Systems version 4.1. So it's a minor update compared to version 4.0. The page that you're viewing this on is likely just showing all the changes, but I figured I would make a quick video just recording an overview of what exactly is different, because for the most part, a lot of what you see is familiar here. So just to quickly show you here, there is a web page that we have all set up on the new website. You'll notice a bit of a change here with the help files and things. But there is a page that goes through. This is our list of changes going through everything. And while it would be interesting for me to go through and just read it in this video, you can go through and do that yourself. But I figure rather than channel my inner James Earl Jones, I would just go through some of these changes and just highlight the main ones. So going through here, a number of these changes are having to do with licensing and activation. So if I quickly go back here, there are some changes to the screen. So the biggest one that we have here is actually the serial numbers that we use are a different type of license on the new website. And the reason I'm so excited about switching over to these is that you won't have to change your license every year. Basically, these are tied to an account. And as long as the account is run by whoever the administrator is for your office or company, as long as they pay the renewal, your license will just continue to function. And so you'll activate it. It looks largely the same. Another option that we have here now is an option to remove your license and move it from one computer to another. There is a policy sort of covering how often you can do this, but basically this is meant for when you get a new computer, you don't necessarily have to contact support, wait for us to get back to you, ask us some questions. We have a form and we have a process for going through and doing that now. And in most cases, as long as it's less than just changing it over once a year, you can actually just do this on your own and you don't have to wait for anything. So I'm excited about that. Getting into the actual technical changes. So we have one about talking about the lambda, which is a variable used taking into account density of the concrete that's used for beam design. I actually do have a post that explains all of this. It's just going to load up here. Explaining exactly how we come up with this number and why we changed it. It's technically a deviation from the CSA standards. But basically, if I show you the file that I have here, the major change is that if you're using a type C unit, the lambda factor that's used, so if I quickly design this for shear, I'll click on detailed results, we'll go through and we'll make sure this designs for shear. Detailed shear results. I go down to lambda, you'll see it's using a value of 0.75. That's important because technically it's 0.85 unless you're lower than a unit weight of 1,800 kilograms per meter cubed. And you'll see here we have this value here. And the reason is in the software, when there's any sort of ambiguity or anything, you tend to want to be on the conservative side of things. For most things, like in particular with beam or wall design, when it comes to the self-weight of masonry, you have a range for the type of, if you're using a type C, the unit could weigh exactly 1,800, but chances are it weighs a little bit less and we're just using the larger value. So the change here is that if you're using a type C and you have this density of 1,800 kilograms per meter cubed, it now uses that more conservative shear resistance factor. Moving on to the next one, sort of going through here. So this is the post explaining all of that. Moving on, we have another, this is for out-of-plane walls. So if you are looking at a design where you actually do require horizontal steel, this is specific to cases where your seismic hazard index is higher than 0.75. So very, very high. There are requirements for needing horizontal steel. And in the case specifically for non-load-bearing walls, we added a message here that appears with the successful results, just basically alerting to you, letting you know that there are other requirements that are not within the scope of what we're looking at within the software. What I mean by that is when the software is designing out-of-plane walls, it's just placing vertical steel, and the horizontal steel gets placed when it's designed as a shear wall. So looking at the in-plane action, the issue is that it's kind of a small gap in the scope of the software where when it comes to non-load-bearing walls, I mean, you're not designing those in the in-plane direction, likely, and so there is no way for the software to tell you by itself if you're looking at a non-load-bearing wall that you might need horizontal steel. So we just added this message here to appear with the successful results, but still alerting you that, well, the software will not place the steel for you. It's not checking horizontal steel. it is letting you know that it might be required. One of the biggest one here is looking at shear amplification. So once again, I do have a full article explaining this, but I also have a file here to show you what the change is. So basically looking at this, I have also a video that I recorded sort of explaining it as well, how you might come up with a shear diagram that looks at what we see there. So rather than watch a video within a video, I'll show you my design that I have here. So basically, when we're designing a wall, we do have a seismic amplification that we do for the in-plane shear. This is based on the codes and standards. And if I look at my base story here, and I look at my shear results, you'll see for my factored shear, it was 170 kilonewtons in my example. However, it's saying that it's designed for 203.7 kilonewtons. So that's just because the standards require you to reach that higher resistance. And so the software does that for you. Now, what was happening before was that when we go to story 2 and beyond, what was happening was it would look at this story independently of the critical section at the bottom of the wall. And so what you might see here is a higher percentage. So going all the way up to 73 if it's conventional construction. And if I quickly go back to this post here, if we look at the example, you'll see that pretty much this was fairly common because as you get further and further away from the bottom, you're going to have more flexural overstrength. And so this was mostly an interpretation that we took when we first added this to the scope of the software. Once again, just trying to stay on the conservative side of however these clauses could be implemented and interpreted. So what we determined when we changed this was that when we're looking at how much we should be scaling this, so in this example that I show in the article, it's 14% instead of 20%. The change that we've made is basically looking at what this critical overstrength is at the bottom of the wall, and we actually apply that same increase for the rest of the height. And so you'll notice in Mass version 4.1, you no longer get these huge amplifications for the stories that are above. It actually uses the same one. Another bug that's kind of in the same neighborhood, I guess, is cases where you might have companion loads. The only case actually where you can trigger this for seismic amplification is if you have a lateral earth pressure at the base. So I have an example here where this scaling actually works a little bit differently. You'll notice that I've turned off a lot of the smaller reinforcement and block selections just so that I have a very large over design. You can see there's a huge gap between my loading and my envelope. So if I take a look at my loading, you'll see basically I have, click on loads here, I have earthquake loads along the height, and then I have a larger lateral earth pressure at the base. And so what will happen now, and this is explained in the notification, the bug article, is that if you look at the shear results for this first story, you'll see I have my, it starts at 220 kilonewtons applied to the base, and it scaled up by 56%. So you'll notice that the percentages change as we work our way up the heights. If I look at story 2 in this case, recall back actually with this first story that not all of this load is an earthquake load, okay? It's, we have a combination of earthquake loads and lateral earth pressures being resisted by the shear wall. So when I look at story 2 and I look at my shear, in this case, we actually, that percentage does go up. And the reason is, it's basically, if your RDRO, those SFRS, force modification factors, were equal to 1.3, so that's the product of RDRO, then this is what your shear force would be if that were recalculated. So we now have a much more involved process of basically identifying whether or not it's this case B or case A that we have in those S304 clauses. I have another series of articles explaining those, but if this is something you want to know a little bit more about, please feel free to contact me. But that's another one of the major changes. And basically what was happening before was that in version 4.0, we were scaling up even the lateral earth pressure by that 73%, even though that didn't necessarily make sense. It wasn't a case that had been considered when we first put it in, so that was our mistake there. So what ended up happening was the software would very conservatively scale up those shear forces even more. And so you'll see there's sort of different layers of conservatism that would get built in here. So going back to this, just to wrap this up, there's another one of the bugs in version 4.0 that we announced where we were using the wrong deflection values, or we were using a much higher deflection value where basically instead of using the elastic values, we were using drifts. And to go from an elastic to a drift, we multiply it by this factor RDRO over IE. But actually, the S304 for the delta F1, which is just defined as the displacement at the top of the wall, it already takes this distinction between drift and elastic into account. So what was happening before was that the software was multiplying it like an additional time, basically, this RDRO factor. And so if we look at an example, we would have, you basically have two different deflections within the software. One is an elastic and one is the final drift. And so now the software, I have a file here to quickly show ductility. If we take a look at this file, so this is a moderately ductile design. And so if I look at my deflection, you'll see we have two different values. We have, this is the drift that's calculated here, but the linear elastic value that gets scaled up is shown here. And so what the software now does is it uses the smaller values. So I can check this by going to my bottom story where the ductility verification is performed. I click on seismic. So this is where the ductility verification is even performed. And then I'll click on detailed results. And so I can scroll down here and see, okay, this is where my inelastic rotational demand is calculated. You see the formula with delta F1. I see what my delta F1 is. It's 12 millimeters instead of like a 36 or whatever it was before. And so once again, you will find that this will make it much, much easier to satisfy a ductility verification if you are having a hard time using version 4.0. So lastly, I just want to point out, I did mention before that there is a whole new website. There's a new software sales website that is up as well. And so if you have any questions about navigating that, please just feel free to reach out to Mass Technical Support. You can call our office or you can send an email and we'll be getting back to people as quickly as we can. But this is a version, I hope you find it useful. I hope the new serial numbers will be something that will save time down the road and some common headaches. And if you have any other feedback or questions, please feel free to contact me. Thank you.